Happy New Year! It's January, and winter has settled in across much of the Northern Hemisphere. The holidays have ended, the decorations have come down, and many people have stepped outside to find the ground has been quietly transformed into a dense, slippery physics problem. Snow looks calm and harmless, but the moment a shovel enters the picture, the laws of motion make themselves very clear. But first, a quick word from my advertisers. Today's Flashcard episode is about why shoveling snow feels so exhausting, why your back seems to protest almost immediately, and why none of this is accidental. The difficulty of shoveling snow is not a matter of poor motivation or lack of toughness. It is the result of force vectors, density, and leverage working together in ways that the human body is not particularly well designed to handle or even fond of. So by the end of this podcast, you still may not enjoy shoveling snow any more than you already do, but you will at least understand why your back has been complaining. When people imagine shoveling snow, they often picture lifting and tossing it aside. This feels intuitive, but it is also where much of the physical strain begins. The difference between lifting snow and pushing snow comes down to how forces act on the body. So, when you push snow along the ground, most of the force you apply is horizontal. Your legs and core muscles are relatively well suited for producing horizontal force. Your feet press against the ground, friction prevents you from slipping, and your body weight helps stabilize the motion. The snow resists your push, but the ground supports much of its weight. When you lift snow, the situation changes dramatically. The force now has a vertical component, which means you are working directly against gravity. Gravity does not negotiate, and that's an understatement. Every kilogram of snow must be lifted upward with enough force to overcome its weight. This introduces a second complication. When you lift a shovel full of snow, the load is not close to your body. The snow sits several inches or sometimes more than a foot away from your spine. This distance creates torque. Torque is a measure of how much a force causes rotation around a pivot point. In this case, the pivot point is your lower back. The farther the load is from that pivot point, the greater the torque that your muscles must counteract. The farther the load is from that pivot point, the greater the torque that your muscles must counteract. Even a modest weight can generate large torque when it is held at arm's length. You are not only lifting weight against gravity, you are also stabilizing a rotating system centered on your spine. Your back muscles are forced to work continuously to prevent you from folding forward under the load. So, from a physics perspective, pushing snow allows the ground to carry much of the burden. Lifting snow transfers nearly all of that burden directly onto your body. So, anyone who has shoveled snow, like myself, grew up in Denver, lived in Virginia, not fun, hate shoveling snow. That's why I live in LA now. But anyone who has shoveled snow more than once knows that not all snow is created equal. Powdery snow often feels manageable, while wet snow can feel punishingly heavy. Yes, punishingly heavy. It's a punishment. The reason for this difference lies in density. Density is defined as mass per unit volume. Powder snow contains a great deal of air trapped between the ice crystals. The air increases the volume without significantly increasing the mass. As a result, the shovel full of powder snow does not weigh very much. Wet snow, on the other hand, contains far less air and far more liquid water. Water is much denser than air, and when snow partially melts or compacts, the empty spaces between crystals collapse. The same shovel volume now contains significantly more mass. This difference can be dramatic. That means the same shovel can weigh several times more depending on the type of snow that you've received. This is why wet snow feels exponentially heavier. Your muscles respond to force, not appearance. A shovel that looks identical can demand vastly different amounts of force to lift depending on the snow's density. The added mass also increases torque on your spine. Because torque depends on both force and distance, heavier snow multiplies the strain on your lower back, even if your posture remains the same. This explains why wet snow often leads to faster fatigue and higher injury risk. Your body may not adjust its movements quickly enough to account for the sudden increase in load, which can result in strained muscles or even a trip to the hospital. Shovel design also plays a surprisingly important role in how much stress your body experiences. Short shovels are particularly hard on the lower back, and physics explains why. You see, when you use a short shovel, you are forced to bend forward more deeply to reach the snow. This shifts your center of mass forward and increases the horizontal distance between the snow and your spine. That distance is the lever arm. A lever arm is the distance between the point where the force is applied and the pivot point. In the case of shoveling, the pivot point is your lower back, and the force is the weight of the snow. A longer lever arm increases torque, which means your muscles must exert more force to counteract the rotation. Yeah, it's a lot of work. So, short shovels effectively lengthen the lever arm by forcing poor posture. Even if the snow itself is not particularly heavy, the increased distance from your spine magnifies the strain. Longer shovels allow you to stand more upright. This reduces the lever arm and decreases torque on the spine. The snow may weigh the same, but the physics changes dramatically based on posture and tool design. This is why ergonomically designed shovels exist. Yeah, they do, and they're not gimmicks. They are attempts to reduce torque by minimizing the distance between the load and the body's pivot points. From a physics standpoint, your back prefers shorter lever arms and smaller torques. Unfortunately, traditional shovel designs often prioritize compactness over biomechanics. And also, unfortunately, traditional shovels are less expensive. Putting it all together, shoveling snow combines several physical challenges into one repetitive task. You are lifting weight against gravity, managing torque around your spine, and adapting to rapidly changing load densities. Short tools amplify these forces by increasing lever arms, while wet snow multiplies them by increasing mass. None of this is a failure of willpower. It is the predictable result of classical mechanics applied to the human body. Understanding the physics does not make the snow disappear, but it does explain why your back complains so loudly. Your body is responding exactly as the equations predict. So the next time you shovel snow, you are not just clearing a sidewalk. You are participating in a live demonstration of force vectors, density, and leverage. Your driveway has become a physics lab, and gravity is running the experiment. So before we conclude, let's go over our 3 flashcards. First, lifting snow is harder than pushing it. This is because lifting requires your body to work directly against gravity while stabilizing torque around your spine. When you push snow, the ground supports much of the weight, but when you lift it, your back and core must handle the full load. Second flashcard, wet snow feels dramatically heavier than powder because it is much denser. The same shovel volume can contain several times more mass when air pockets collapse and liquid water fills the space. More mass means more force, and more force means greater strain on your muscles and your joints. And the third flashcard, short shovels strain the spine because they increase the lever arm between the snow and your lower back. This larger distance magnifies torque, forcing your muscles to work harder just to keep you upright. Longer or ergonomically designed shovels reduce that distance and lower the mechanical stress on your body. So together, these 3 factors explain why shoveling snow is such a punishing task. The challenge is not just the cold or the repetition. Well, it is, but it's also the combined effect of gravity, density, and leverage acting on the human body. So remember, your back doesn't hate you. Your back hates torque, density, and poor leverage. So as you combat the horribly snowy winter that many of you are facing, I wish your back much luck. Stay dry out there, stay safe, and until next time, carpe diem.